guys, welcome to another episode of Huda Education. Today, I just wanted to clear up some loose ends as it relates to, how the data is laid out in the buffer. Specifically, I guess you would say this guy right here. Okay. A couple videos back, we sort of picked apart each one of them. And, this is our application for those that are brand new to the video. It's basically you're displaying a bunch of objects and, they're all over. But if you press the freeze frustrum thing, you cull out everything that's outside of what the camera can see. So if I pan left or pan right or pan up or pan down now, you would notice that the objects disappeared because they were not immediately visible in our view space. If I unfreeze the frustrum, notice that all the objects display again. There is also a level of detail aspect to this application where basically the objects that are closest to me have the most detail, most intricate mesh, most expensive processing, and the items that are further behind the camera or away from the camera has less detail to save on the processing, right? So the mesh isn't as intricate and complicated, and it's dynamic. So as I move forward, notice that the yellow stuff becomes green, and you will notice that if I zoom forward enough, the red will disappear because it's dynamic, right? However, if I freeze the frustrum and just leave everything as is, and I zoom in, notice that the images now, because I froze everything, the image starts to degrade. So you notice that the quality of the image starts to degrade, right? And that makes sense because we are, we're farther away. So it's not like the viewer can appreciate what's going on back here, right? So if we unfreeze again, then we get, So anyway, that's the quick overview of the application. In the previous video, we extensively talked about the different aspects of how we make this happen, right? So, we have things like indices, instance count. So instance count is the number of objects. Index count is the indices, the amount of indices to create the mesh. First index is where we start. Vertex, offset, and first index and first instance, right? So what I wanted to do is first of all, let's pull up back my notes. Okay, so we have our notes here. We have the application here. We have our notes here, and it's just one big mess. But we like big messes, right, guys? We like big messes. So we have our application. So level of detail 0 is where we get, the most complicated meshes, the most detailed meshes. And we could see that level of detail 0 has the most indices. Indices is the label for the vertexes. So we have vertexes, but then we label them, we call them indices. And notice that level 0 has the most indices, right? As we go further back, the yellows, the orange, the red, we get less indices, basically less complication in the mesh. And as you guys know, when we zoom all the way in, notice that the mesh degrades, right? That's because we are now at level 2 and the meshes degrade. As we zoom back out to where we originally were before we froze the frustrum, we see that we have, right? So level of detail is basically, how many indices do we put into each object, right? We have vertexes, indices, right? So these are the indices. We have instance, which is XYZ. So the instance is a location of the object, right? So where do we put the object, right? And the scale. So are we going to double the size of the object, triple the size of the object, or half the size of the object, right? And basically, we just compress the object, right? Based on the indices or the indexes, right? So that's that here. But what I wanted to do is show you guys exactly what's happening in Nsight Graphics. So guys, just so you know, Nsight Graphics is a tool that is available for people who have NVIDIA GPU. So if you have an NVIDIA GPU, you could run Nsight Graphics. And what Nsight Graphics does is it gives us a way to dive deeper into what's happening in our application. So in Nsight Graphics, we are going to see that we have our draw calls, VCMD draw indexed indirect, which you guys know already is VKCMD draw index indirect. I'm running this one where I just submit one command and it does everything on the GPU side. I'm not for looping each draw command or what have you. I just send everything to the GPU and then the GPU reads the buffer and and it draws everything. So I just wanted to dive into this. So notice that we have our index count. Okay. Our index count now is going to be related to, and we could do this. Do I have enough space? Okay, so our index count is basically the number of indices for the specific object. So this is inside of the buffer, right? So we're in VK CMD draw index indirect, and this is inside of the buffer, right? And we're basically laying out all of the information inside of it. That's basically this buffer right here, right? The buffer for when we're going to draw. So notice that we have indices here. So we have an index count of 360. We have instance of 0. With instance of 0 means that these objects were not drawn, right? These objects were not drawn. We have first index of, whatever it is, and vertex offset is just vertex offset. And then we have the first instance is, where do we, which object is this, right? Which object is this? And that is pretty much it. But what I wanted to do was, right. But what I wanted to do was is notice that as we, let's say, okay, so notice now we have a different object now where the index count changes, and that what this means is that the level of detail for this particular object is now, instead of it being 360 indices, it's now 726. And that makes sense because let's say we went from level of detail 2, which is less indices, to level of detail 1, which is more indices, right? Almost more than double plus, right? So we now have more indices. We're actually displaying we're displaying the object because instance count is 1. The first index is it's a different mesh, so the first index also changes. Notice that this index is here and this index is here, right? So it's a different mesh, so the indices that we are actually reading is the set of indices that we're reading is different. I'm willing to guess that if we were to add this plus this, we would get this, but I might be wrong, right? If we add this plus this, we'd get this number, right? So we're starting to read a different set of indices, and then we read all 726 indices, right? So that's that. Vertex offset is 0, and then the first instance is, we're dealing with a different set of objects, so this is basically telling you where the object is placed and all of that, right? The first instance. And that's pretty much it, guys. This is inside of Nsight Graphics, right? So we I ran the I ran the program, and basically it was a frame capture feature where you basically can you could basically dive into what's happening in the buffer. And again, what I mean is what's inside of this guy right here, right? We submit the buffer, and then the GPU loop, the GPU basically reads all of the instructions inside of the buffer, right? And that's what this guy is, right? So real quickly again, we have our draw count that just increases incrementally. The index count is a number of indices. And notice that, do we have another set of numbers? Okay, so notice that we have so this one, we have even a bigger index count, which basically means it's probably LOD 0, which is the object that is closest to the camera. We are displaying it. Instance count is 1. The first indices, again, it's a different set of indices that we're reading. So it's this guy. I'm willing to bet if we added this plus this, we would get somewhere here. I don't know, but again, the indices it's a long list of indices, but every LOD is a different mesh from the previous one. Every LOD is a different mesh from the previous one. So so we have to know where do we start building the new mesh? What's the instruction for the new mesh, right? So that's what the first index is. Vertex offset is 0 still. And then first instance, we're basically telling which object we're drawing and where is the location of the object. And we know that because the instance data tells us XYZ and it tells us the scale, right? So position coordinates and the scale value, okay? And that's pretty much it, guys. But this is inside of the buffer, all right? I'm gonna, I just wanted to focus this video because I don't want to confuse you guys. But this is how all of this works, right? So that's how we get our application, and we have, all that's going on, right? And then again, if I unfreeze, I'm gonna get back the entire list of objects, right? This is CUDA education. Guys, if you want to be able to learn computer graphics, learn Vulkan API, you need to have a Windows-based machine with an NVIDIA GPU. The reason I say NVIDIA for this time is because in order to run Nsight Graphics, you have to have an NVIDIA GPU. So you need an NVIDIA GPU. You need a Vulkan-capable GPU, and if you want to run the ray tracing stuff, you need to have a ray tracing capable GPU. Now, for this particular example does not use ray tracing, so you would be able to run it if you don't have a ray tracing capable GPU. But it always has to have a Vulkan capable. It has to be a Vulkan capable GPU. For NVIDIA, I know it's a RTX series and greater. I don't know how far into the future you'll be watching this video, but for NVIDIA, it's a RTX series. For Intel and AMD, I have no idea, right? But again, if you have Intel or AMD GPU, you will not be able to run Nsight Graphics, which is a tool to help us, get more information on what is happening in our application. So there you have it, guys. You understand what draw is, you understand what index count is, you understand what instance count is, you understand what first index, vertex offset, and first index and first instance. That's like a tongue twister. Notice that the draw count just increases linearly, but we're doing many draws, right? So it's 262,000 plus draws that we're trying to manage. And also notice that the decision to draw or not to draw an object is implicitly decided in this instance count parameter, which is, if we look in here, it is normally the second to last parameter. So for this guy, you would see, I mean, this is a fallback command, but you will see that we have the instance count of 1 here. But that is draw count, right? So you see the draw count, right? So we implicitly decide what to draw or not to draw by manipulating whether instance count is 0 or 1. So for all of these objects that is 0, we're not drawing. But then for the objects that we do have a digit, we are drawing. Okay? And that's how all of this stuff is decided. So you could see most things are not drawn, right? Because it's like outside of the frustrum. And then just to be complete, we decide, you know, whether to draw or not to draw. Check if the object is within current viewing frustrum. So we decide if it is, we draw. If it is not, we don't draw. Instance count is 0. Okay. This is the compute shader on the GPU. So this is being decided on the GPU. And what it does, it just basically manipulates what's inside of the buffer, right? And then the GPU just reads the buffer and does as what the buffer says. All right. Thank you guys for watching. Have a great day.